Some days ago, I published my number visualizer node group together with a detailed video tutorial on building it. Since then, I've added more features to it, making it easier to work with. It's a blazing fast setup because the only thing it generates is instances, and it is also optimized to work great with fields. As long as you have geometry points, you can use this node group to view any attribute attached to them or generate and render any range of numbers possible. I've called it simply Visualizer, and today I'll demonstrate some cases where you might find it helpful. In the first example, we'll make it show the index number of points, polygons, and edges on the screen. Start with inserting a visualizer node after the default cube. Set the 3D view to wireframe mode. Also, join the default geometry with the visualizer output. By default, all you see on the screen are zeros. That's because we have still not fed the node any attribute to visualize. Connect an index field to the attribute input and enjoy indices on the screen. The numbers are renderable also. I've added horizontal and vertical alignment controls to the node group so you can align the numbers in relation to the points they are positioned on. On the horizontal axis, the values -1, 0, and 1 represent the right, center, and left alignments. Just for test purposes, let's add some decimals to our indices and play with the horizontal align values. You can also align the text vertically. The same principle applies. Center both horizontal and vertical axes and lower the decimals to 0. Apart from alignment, you have the option to offset the numbers in whichever direction you like and also rotate and scale them. You may find the rotation input particularly useful when you need to have the numbers face the camera. To see this in action, view the scene from the camera's perspective by hitting 0 on the numeric keyboard. Zoom in and on the View Properties tab, activate Lock Camera to View. Now drag the camera object from the outliner to the node editor and connect its rotation vector to the rotation input of our visualizer. And like magic, all the numbers point directly to the camera, no matter how we move it around. Useless to say, this works with any geometry you feed at the node group. As long as there are points, the visualizer will always show their indices. But how does it work with faces or edges? That's simple too. Just insert a Mesh to Points node before the visualizer and cycle through Points, Edges, or Faces mode. There you have it, a fully working index viewer. But my visualizer can do much more than that. It can render out any attribute you throw at it. In this example, we have a star-shaped curve. Add a Points node, generate 10 points with it. Making the points slide around the spline is what we're going for. Attach a Set Position node to the points. Also, add a sample curve to the star. Connect the Position Out vector to the input of the Set Position node. And join geometries together. To space the points along the curve length, we need to divide their index number by the total number of points. The domain size returns us the total number of points. So, add an index node together with a division math node. Just remember to change the domain type to point cloud. Feed the division result to the factor input of the sample curve. We'll animate them around using the scene time node. Let's say we want each point to complete a full circle in 20 seconds. Divide the seconds number by 20 and add both division results together. In the end, add a modulo of 1 so the points keep looping after they reach the end of the spline. Preview the result. Now, let's visualize the factor value for each number. Append the visualizer node after the set position. Connect the modulo output to the attribute input and join the output geometry with the rest. There you are. Each point shows the exact vector along the spline it is traveling along. But why stop there? We can show the position in the world space for each point. Sever the vector nodal and add a position node instead. Separate the coordinates and connect each one to the attribute input. As you can see, the attribute input only accepts float values. That's intentional. To keep the setup light, I didn't include a vector variable to it, but it's really easy to make it work. Duplicate the visualizer twice and replace the attribute input with the remaining coordinate values. Join all three visualizers together and then join them with the rest of the geometry. Align all numbers to the right horizontally and translate X and Y numbers up. Hit play and watch the vector values animate in all their glory. In addition, to visually separate coordinates, you can add a different material to each one of them. That's up to you. As you have already guessed, numbers don't necessarily have to be meaningful attributes at all costs. You can generate random values also. They are useful for all kinds of typographic effects. In the last example, I will show you how to build a cloud of randomly changing numbers moving in space. We'll start with a volume cube, followed by a distribute points in volume. Attach a set position node and feed a combined XYZ to the offset input vector. We'll animate the set position with a noise texture. Change the number of noise dimensions to 4 so we can procedurally animate it using time. Divide the number of seconds by 20 to slow it down and connect the result to the W input. Now the noise texture outputs values in the range from 0 to 1. We can widen that range with a map range node. Set the input range from 0 to 1 and the output from -5 to 5. Tweak the settings as you see fit. Hit play. We have a cloud of points moving up and down. Now let's attach random numbers to them. Add a visualizer node group and feed the range map output to the attribute input. Now you can travel with your 3D camera through this random number cloud. Nothing stops you from adding another range map to separately control the range of numbers to display. You can build lots of GUIs for sci-fi projects with it. I showed you the tool. Probably you can make beautiful things with it. These are only a few things you can do with the number visualizer node group in Blender. It should be a built-in feature, but following my tutorial, you will learn how to build it yourself. Or if you are lazy and just want the node group to play with, you can download it from the link in the description.